So, hello everyone, welcome to QPhysics Academy. Uh, in this lectures, we are actually describe the previous year solutions of Jest 2024. And in this sections, we discuss some questions like 6 or 7 questions. In next video, we add the next lectures also. Okay, so this is the first questions. You just notice here in your screen. This is the first questions of JS 2024. In these questions, the three equal charges plus q are placed at the corners of an equilateral triangle, and a test charge constrained to move on the plane of the triangle is placed at the center of triangle. Which of the following statement about the test charge is actually true? So if we draw a triangle, right, this is a triangle, and three positive test charge are placed at the three corners of this triangle, and they placed again a test charge at the center of this triangle. This is the locations of test charge, right? This is the locations of test charge. Test charge is either positive or either negative. We just based on this configurations of this sign conventions of this test charge, we deal these problems actually. Okay, if we place a positive charge at the if we place positive charge, right, if we place positive charge at the test charge locations, then repulsive force is acting between all the charges placed at the corner of these triangles. Okay, it means equilibrium conditions is actually break. Equilibrium conditions is actually break. Again, if we consider consider this is the same triangle, right? Same triangle. Okay, if we place a negative charge at this test charge locations, then attractive force is acting between all the charges placed at the corner. So basically, this two repulsive force and this attractive force equilibrium conditions actually broken. So the stability of equilibrium depends is actually on the sign of this test charge actually. If there is no test charge, then equilibrium conditions is actually stability condition is actually dominated is here actually. So if test charge is positive, then stability condition is broken. If test charge is negative, then stability condition is again broken. So the stability of this equilibrium conditions depend on this sign of this test charge. So answer of this first question is A. So this is a conceptual question. There is no mathematical solutions. That's why I not write here. Again, next we go to the next questions. Actually asks in classical mechanics. Okay, in the second questions, a classical system has a actions as integrations where q is a generalized coordinate. Okay, q is a generalized coordinate and alpha and beta are the constant. Which of the following statement is true about the dynamics of the systems? So dynamics of the systems is depends on alpha and beta. Dynamics depends on only alpha. Dynamics depends on only beta. Dynamics depends on ratio of alpha by beta. So dynamics, if we deal with dynamics, first of all we calculate the equation of motions of the systems. So for find out the equation of motions of the systems, you need to calculate you need to know the Lagrangians of these systems. So here the actions is like that. This is represented as equation number 1. We have no actions is defined as S equals to integrations L dt, where L is the Lagrangians of the systems. So if we compare these equations 1 and 2, we get Lagrangians these are of the given systems. So okay, now we have a Lagrangians of the systems. So now we calculate the equation of motions. So for calculate equation of motions, we use the Euler-Lagrangian multiple equations. Euler-Lagrangian equations. This is equals to d by dt del L by del Q dot minus del L by del Q. Q is the generalized coordinate here. Okay, Q is the generalized coordinate. From equation 3, we just equation 3 here, and let's do simple mathematical calculation. If you please note down from this videos, just this is very simple mathematical calculations, and you get a equations, right? Q double prime double dot is equals to 0. It means second derivative of the analyzed coordinates is equals to 0. It means the dynamics is independent of alpha and beta actually, right? Dynamics is independent from these equations. We easily say the dynamics of these systems, dynamics of the systems is actually independent of alpha and beta. So options A is the correct answer, right? Option A is the correct answer. Okay, clear? Option A is the correct answer. Okay, next we go to the next questions. Okay, question number 3. A and B are two cross true Hermitian matrix. A and B are two cross true Hermitian matrix. A1 and ket and A2 ket are two linearly independent eigenvectors. Okay, there's two eigenvectors A1 ket and A2 ket of A. Consider the following statement. There actually mentions two statements. If A1 ket and A2 kets are eigenvectors of B, then if A1 ket and A2 kets are eigenvector of B, then A and B are commute each other's. And the statement is, if A and B commute each other, then A1 ket and A2 kets are eigenvectors of B. It means we already know if two vectors, actually here mentions two vector, right? One is A cap operator, another is B cap operators, and these two operators when commute each others, then they have a simultaneous eigenfunctions. It means they are common eigenfunctions. It means A cap have a eigenfunctions alpha 1 ket, alpha 2 ket. Similarly, B1 have a eigenfunctions alpha 1 ket and alpha 2 ket. So if two operators have same eigenfunctions, right? If two operators have same eigenfunctions, then these two operator must be commute each others. But there have contradictions. Right? But there have a contradictions. So I just clear here the point. Okay, I just clear the points. We have two operators, right? We have two operators A cap and B cap. We have two operators A cap and B cap. A cap have eigenvector alpha 1 ket and alpha 2 ket. B1 have eigenvector alpha 1 prime ket and alpha 2 prime ket. Okay, what happened actually? If these two operators are commute each others, right? If these two operators first they commute each others, then what happened? These two operators have same eigenvalue. These two operators have same eigenvalue. A cap and B cap have same eigenvalue, but they have not common eigenfunctions, but they have not common eigenfunctions. So it means statement 2 is wrong, right? Statement 2 is wrong. But if two operators, but if these two operators have same eigenfunctions, so it's definitely commute each other. So please remember this. Two important notes. If two operators have common eigenfunctions, okay, then they must commute each others. But if they commute each others, then they have common eigenvalue but not common eigenfunctions. Okay, please remember this important statements. Okay, so that's why here a1 ket and a2 kets are eigenvector of A. Similarly, if a1 and a2 are eigenvector of B, then it must be commute. But if they commute, it's not necessary the eigenvector of B is same like A vectors. Okay, that's why options A is that's why statement 1 is true, statement 1 is false, right? So please remember this important statement. It is very important for JAM examinations, for MSQ type questions, right? So this statement is very important for MSQ type questions. So please remember. Next we go to the question number 4. Next we go to question number 4. It is very good questions from thermodynamics. This question is asked from thermodynamics. So an ideal gas initially at pressure Pi undergoes the following sequence of process. There is some sequence of process: reversible adiabatic expansions, and reversible isothermal expansions, and reversible isothermal first is compressions, reversible isothermal expansion, and reversible adiabatic compressions. So mainly there is sequence of process: reversible adiabatic expansions, reversible isothermal compressions. So okay, if like this question is from like Carnot engine, right? If we draw a Carnot engine PV diagrams, first is expansion, like that. A, B, C, D. So yeah, it is actually I have here some mathematical calculations also, but in this video we deal it in very conceptual way. It's nothing but a Carnot engine. It's actually mentions here the Carnot engines. So from first is reversible adiabatic expansions, we know already. This is the adiabatic curve, this is adiabatic, and this is isothermal. This is actually adiabatic process, and this is the isothermal process. So first is adiabatic expansion, then isothermal compressions, and then again it's a adiabatic compressions, and then isothermal expansions. So this is the process actually. After this process, the final pressures of this gas PF is actually what? It's equal to initial pressures, is greater than initial pressures, or is less than initial pressures, or the relations between depends on the initial conditions. But you notice here, this process is actually does not follow, this process is actually does not follow the Carnot engine. Is not exactly Carnot engine, because the process 3 is actually reversible adiabatic compressions होना चाहिए था, but it is not. Actually they flip this to a process. That's why this is not follow the Carnot engine. So please keep in mind, right? First two process follow the Carnot engine process, but last two process is not follow the Carnot engine process. So these questions for exact solutions, it does not follow the Carnot engines. We follow the basic mathematics of thermodynamics. Step 1, a reversible adiabatic expansions that double its volume, actually that doubles its volumes. So we have a adiabatic equations, and then find out the final pressure for this first equations for first process. Next is a reversible isothermal compressions that restores its original volume. It means the volume of V3 is equals to initial volume. For isothermal process, we have a equation of motions, PV equals to constant, hence the volume decrease, hence the pressure increase to original pressures. Obviously, as volume is here decrease, volume is actually decrease here, so pressure will increase. So pressure is step 2, pressure is equals to P3 equals to Pi. Next is step 3, a reversible isothermal expansions. A reversible isothermal expansions that double its volume again doubles. So V4 is equals to 2Vi. Again isothermal process, so we use the isothermal process gas equations. So P3 V3 equals to P4 V4. So from these equations, P4 equals to P initial upon we just calculate P initial upon 2, P initial upon 2. Next step 4. Step 4 is reversible adiabatic compressions, and that restores its original volumes. So that's why P5 is equals to Vi is here, and this is the reversible adiabatic process, and we use these adiabatic equations, and finally we calculate the P4 is equals to Pi. Hence you just follow the mathematics and you easily calculate. Okay, you just follow the mathematics in very simple way, right? So hence the final pressure of the gas is equals to the initial pressure. Okay. Next we go to the so for these questions, answer option is the correct answer. Okay, we just follow this very simple mathematics, gas equations. For adiabatic process we use the gas equation, and isothermal process the gas equations. Adiabatic process gas equation PV gamma equals to constant, and isothermal process gas equation is P equals to constant. We just use these two equations and we calculate the final pressures, right? Okay, next we go to the question number 5. A quantum harmonic oscillator with energy levels En equals to n plus half h cut omega, where n equals to 0, 1, 2, 3 and so on, is in equilibrium at a low enough energy temperature, so that the occupations, it's very important point, so that the occupations of all the states with n greater than or equal to is negligible. Okay, we all the state n greater than equals to 2, it is negligible. What is the mean energy of the oscillator as a function of inverse temperatures? So for we actually calculate the mean energy for only two state. N equals to 0, this is ground state. This is very easy questions, right? Ground state, and n equals to 1, first excited state. For these two states, we only calculate the partition functions and then mean energy. This is the main funda of these questions. First excited state. Okay, is it clear? So n equals to that is, so for n equals to 0, we have the energy equals to h cut omega by 2, and for first excited state we have energy 3 by 2 h cut omega. Okay, now the partition functions of the system for occupation number n less than 2. N less than 2, it means n equals to 0 and n equals to 1. So we know the partition function. Exact formula of the partition function is summations over e to the power minus beta ei, right? This is the exact partition functions. Here I equals to actually 0 to 1, 0 to 1, it is the exactly I equals to. So for beta here e to the power beta e0 plus e to the power minus beta e1, let's substitute the value of e0 and e1, and let's take a common e to the power minus beta h cut omega upon 2, so it is equals to 1 plus e to the power minus beta h cut omega. Okay, now we calculate, this is the partition functions of the system. Okay, this is the partition functions of the systems. Now from these partition functions we calculate the mean energy. We know the exact formula of this mean energy. It's equals to summations over en e to the power beta en n upon partition functions. Okay, this is the exact formula of this mean energy. We just use this. So e0 plus beta e0, beta is equals to inverse temperatures. Here beta is equals to 1 upon kBT, inverse temperatures, don't confuse with that. So e0 plus beta e0 plus e1 plus beta e1 upon z. Next e0 equals to h cut omega upon 2 e to the power beta h cut omega. Let's substitute the value of e0 and e1, and then we take a common h cut omega upon 2, and e to the power minus beta h cut omega upon 2. So this is equals to 1 plus 3 e to the power beta h cut omega upon z. Okay, let's substitute this here. The value of this partition functions, and then e to the power minus beta h cut omega upon 2 e to the minus beta h cut omega upon 2 cancel each other. So finally we get h cut omega upon 2 1 plus e to the power minus beta h cut omega upon 1 plus beta e to the power minus beta h cut omega. Now next simplify this 1 plus 3 e to the power minus beta h cut omega for further calculations. So this is equals to 1 plus e to the power beta h cut omega plus 2 is beta h cut omega. Okay, so this is equals to 1 plus e to the power beta h cut omega upon 1 plus beta h cut omega, 1 plus beta h minus beta h cut omega plus 2 e to the power minus beta h cut omega upon 1 plus e to the power minus beta h cut omega. So these two terms is actually cancel each other, so we get 1 plus 2 e to the power beta h cut omega, and we just simplify these equations and we get the mean energies of these systems. So this is equals to h cut omega into half plus 1 plus e to the power plus beta h cut omega upon 2. So this is very simple calculations. You just follow these calculations. I here calculate in details, very simple way. Okay, I also very simple way I just calculate. You just look the videos and pause the videos and note down and solve it. It's very easy problems, right? So don't worry. Okay, don't worry, I just solve here very clear solutions. I'm not thinking when you when you put down all the solutions, you feel, oh, why this step is occurs. Actually, I mention each and every solutions in very simple way. Okay, so for these questions we get options A. Sure. Okay. Okay, next is question number 6. Next is question number 6. A particle moving in one dimension. Actually, why I'm not solving during videos, because each solution is very long, right? If if I ready, if when I record my videos and that time I write each and every solution, then I am not able to give you majority number of solutions. So my motto is I motto is motto is I will give you more number of question solutions, right? So that's why I first write all the solutions each and step, and then I explain the step in precise way. Okay, actually what I actually doing. So a particle is moving. Okay, let's concentrate again in question number 6. A particle moving in a one dimension has the wave functions. There is a mention. Alpha is a real positive, and k0 and k1 are the real. The expectations value of momentum. What is the expectations value of momentum? What is the expectations value of momentum? This is the questions. Okay. So the wave functions is here. So next we do the complex conjugate of these functions. Okay, next we take complex conjugate of these wave functions. Complex conjugate, you just mentions here, I just exponential minus alpha x plus, because I complex conjugate of I is equals to plus I, that's why x plus I k naught upon alpha whole square sine square k1x. Okay, next expectation value of momentum. This is the exact formula of this expectation value of momentum. Minus infinity to plus infinity psi star, this is the momentum operator, right? This is the momentum operator, minus I cut del del x psi x. So okay, so this is equals to actually minus I h cut minus infinity to plus infinity psi star del psi of x upon del x into dx. So first of all we calculate the derivative of this wave functions. Okay, first of all we calculate the derivative of these wave functions. We just calculate here the derivative of these wave functions. Okay, this is the first line, and next del del x exponential minus alpha x minus k naught I k naught upon alpha whole square sine square x, and then derivative of the sine square functions. Now derivatives of the exponential part, derivative of the sine square part. Differentiate the Gaussian term. I differentiate the Gaussian term and we get this value. Okay, next we differentiate the sine square k1x term and we get these results. Next we substitute these two results in the previous equations and we get this results actually. Okay, you just follow, this is very simple solution, and then we substitute these solutions, and this is your homework. Majority of these calculations I am actually done. Okay, I'm actually done in this video. You just calculate the two lines. Okay, you just calculate the two lines. What is the exact solutions from this integrations? If anyone feel hesitation or difficulty to solve these integrations, feel free comment. Okay, so finally we get this solutions of this integrations is equals to 2h cut upon k naught. Okay, you just simply calculate this integrations, very easy solutions, step by step calculations. You just very simple play, you just play with integrations, right? This is the part from this line to this line, this is the playing with integrations, right? So you play, right? You play with integrations and then you get the solutions 2h cut upon k naught. This is your homework part. Please done it, sorry, please do it, not done it. please do it. Okay. Okay, so in this video I discuss 6 questions, and next video we again discuss another 6 questions. In this way I definitely complete the Just 2024 sessions. Okay, and again thank you for watching this video. If anyone feel I have I have I have get some benefit from this YouTube channel, please subscribe and like this channel and share with your friends who are preparing for those examinations, CSIR, GATE, Jest, TIFR, etc. IIT JAM. And this lecture series, I sure it's help us of your friends, right? So please like and subscribe. Thank you, and thank you for watching this video.